Today we're going to talk about direct modeling for multiplication. So direct modeling is a way that we can create representations of the multiplication problem we're being asked to solve. So let's take 6 times 34. For an example, we're going to look at 3 models that I have on my computer. Okay, so we can see 1, 2, 3, 4, 5, 6 of the yellow circles, right? The big circles, almost ovals. So our problem is 6 times 34, so there's our 6. And within each of these circles, the 6 circles or ovals, we see 34 dots in each of these ovals or circles. So this one has 34, 34, 34, 34, 34, 34. So this represents 6 times 34. And if we need to, we didn't know how to solve 6 times 34, we could go through and count each one of these individual dots, and that would give us our answer. But that would take a lot of time. So let's look at another one. This is another way to represent 6 times 34. So let's count how many groups we have. 1, 2, 3, 4, 5, 6. We have 6 groups, and within these 6 groups, we see our tens row or tens block. We see 3 of the tens blocks, so 10, 20, 30, and then we see 4 individual units, so that equals 4. So we have 34. We have that for each group of 6. And again, we could go through and count all of these up if we didn't know how to solve 6 times 34. But what's nice about using the tens blocks and the units is that we know this is 10, 20, 30, and 4. So it'd be a lot easier to go through and count our tens and then count our 4s and add those up than counting each individual dots like we would have to do up here. So let's look at the last way. So let's break it down a little bit because 6 times 34 is a little bit daunting. So we could do 6 times 30. So 6 times 30, we could multiply the 6 and the 3 and then add the 0 on at the end for our answer. So that would be 6 times 3 is 18 and add that 0 on at the end, and that's 180. Then we could do 6 times 4, okay? And then we could add 180 to 6 times 4 and get our final answer that way. So that is direct modeling for multiplication. You can do it countless different ways. It's easier if you're solving a big problem to use your tens blocks and your individual units, or, I don't know why I just did that, or use this model down here of breaking up the multiplication problem and finding the answers, individual answers, and then adding them together.